You all know light is a form of energy, like any other energy. For example, sound energy, heat energy, and so on. Light helps us to see the things. For example, if there is an object, let's say flower, which is there in front of your eyes, and when the light falls on the flower, you all know that it reflects. It reflects light in all directions. Some of the light which are reflected enters into our eye and then able to form a small inverted image right on the screen of the eye, which is called retina. Point to be noted here that it is a reflection of light which helps us to see the things. In this case, it is a reflection of light from flower. We see flower. Suppose, let's say it's dark and you have blocked the light. No reflections from flower and no image formation on retina. So first of all, it's the light which helps us to see the things, and objects are visible when they reflect light. You see, all around you, things which can reflect light are all visible. In this case, a tiger, when reflects light, it is visible to a person who is in front of him. So once again, light helps us to see the things, and objects are visible only they reflect light. But when light reflects, it follows certain rules, and those rules are formulated as law of reflection or laws of reflection. We shall have a demonstration to understand laws of reflection. Well, we shall understand laws of reflection with this demonstration. I have source of light here, and this will help us to get a beam of light. I also have a plane mirror because we have to direct a beam of light on this plane mirror. And to create a beam of light, I have got a small slit you can see here. And to focus the light, I have a lens here, convex lens. So what I do is, I am going to keep this here and then insert the slit here into this groove and then keep this base right in front of it, and we got a beam of light. And this beam of light reflects when it falls on the plane mirror. You can see that. Now please remember, the light which comes from the source is called incident ray. I repeat, incident ray. And where it has fallen right here on this point on the mirror. And that point is called point of incident. And then it reflects here. So this ray is called reflected ray. So once again, incident ray, point of incident, and then reflected ray, right? Now I want to measure angle. To measure angle, I have a protractor with me. But this is along with the plane mirror here, you can see. So I'm keeping this one in place of the previous plane mirror right here. Now once again we'll recall. This light ray is called incident ray and this one is called reflected ray. It reflects, it bounces back,
and the point here is a point of incident. And then this line which is drawn, which indicates a 0 degree, right? This is called as normal. Normal is anything which is drawn perpendicular to the plane. Let me repeat. Normal is a line which is drawn perpendicular to the plane of the mirror. Right? And now we can find out the angle on either side of this line. So if you can see here, this particular angle, which is between incident ray and normal, incident ray and normal, this angle is called angle of incidence, and the angle between reflected ray and normal is called angle of reflection. Now how much is that? Let me find out angle of incidence here. You can see here 20 degree is written here. So angle of incidence is 20 degree from here to here. Now look at the angle of reflection. Angle of reflection is also 20 degree. Now I am going to change the angle of incidence. You all know angle of incidence is the angle between normal and incident ray. And now you see angle of incidence from here to here is 40 degree, and you will find angle of reflection is also 40 degree. Which means as you change angle of incidence, angle of reflection also will change with the same magnitude. So what we can conclude here is angle of incidence is always equal to angle of reflection. This is important point. I'll repeat, angle of incidence is always equal to angle of reflection. The second point is, look at this incident ray and reflected ray, also the normal. All three lie on the same plane, right? This is important. Another second point it is. Now I am going to reduce this angle of incidence. What is the angle of incidence now? It is 20 degree, and angle of reflection is also 20 degree. Now angle of incidence is 10 degree, angle of reflection is also 10 degree. Now if I take a incident ray right on the normal, the reflected ray goes back along the normal, and so angle of incidence and reflection both will become 0.
Let us watch this animation. You can see here top view of the law of reflection diagram. Incident ray, reflected ray, as well as normal. Now if you can turn around and go on a side view, you will find the reflected ray is slightly upward. It is not on the same plane. But what we have learned is incident ray, reflected ray and the normal requires to be on the same plane. That means this animation is wrong. Now did you understand what do you mean by incident ray, normal and reflected ray are always lie on same plane? A red color platform represents a plane, and now you can see here incident ray, reflected ray and normal all lie on the same plane, and light behaves like this. So remember this tutorial, we shall try to draw the ray diagram of laws of reflection. But if a question comes like state laws of reflection with the help of diagram, then you have to draw it properly on your answer paper, and that is the reason we have taken a background as just looking like your answer paper. So what you have to do is make use of the line which is already drawn on the answer paper. So I'll take a scale and draw a straight line because I want to draw a mirror first, right? And to make it as a mirror, you have to show a non-reflecting side, in the sense, a rough side of the mirror by just shading it on other side. So what happens here is the front side, that's a downside, is the smoother side, and now we shall take a incident ray, right? So use a scale and draw a light ray. Now you have to call this as a ray because you have shown an arrow mark to this line, and that indicates a light ray. Okay, if you simply draw a light line without an arrow mark, it is not a light ray, right? And then you have to use your protector. This is a very important step, right? Now keep that protector as shown in the figure now and look at 90 degree where it is. Make a point there and draw the straight line perpendicular to the plane of the mirror. And what is that line called? That is what is called normal. And the next one is, then the incident ray reflects on other side. But here you have to find out where that reflected ray will go. Now look here, this angle, this is right from here to here, it's 120 written, right? It's 10, 20 and 30 degree, right? And so this side also it has to go for 10, 20 and 30 degree, right? So from here to here 10, 20 and 30, and again from here to here 10, 20 and 30. So how much is the angle here? 30 degree angle, and here also you should have a 30 degree angle. So your line which you are drawing should be exactly making 30 degree with the normal, right? This is what you have to draw properly. If your angle appears different here, then your diagram is not correct, you may not score mark. And once you do this, okay, then you have to label the diagram. So what is that? This is what is called a plane mirror, right? So first one is plane mirror, second one is incident ray, right? The next one is this ray. This is what is a reflected ray, right? Now the next, a point of incident. So what is point of incident? This is called point of incident. Where incident ray hits on the plane mirror is called point of incident, right? Angle of incident here. We have to show an angle of incident. This from here to here, it's the angle of incident. Remember, since this is normal, right? Look at this. This is normal, and the angle between incident ray and the normal is angle of incident. And in the same way, this angle from here to here, it is angle of a reflection, right? So this is what is the diagram. After that, you have to write the laws of reflection. And what are the laws of reflection, right? First law is angle of incidence. This is called angle I, and angle of refraction is called angle R. Angle of incidence is always equal to angle of reflection. And second law you already learned, that's incident ray, so this ray, right, and normal and reflected ray all lie on the same plane. I'm sure you have understood what you mean by they all lie on a same plane. So your diagram as well as the laws should be written in this way. As far as diagram is concerned, particularly ray diagrams, they appear very simple, but unless you draw and practice again and again, you may not reproduce in the exam. That's why when you simply watch this video and leave it, then it's of no use. You have to right now take a paper and compass box and draw it some 3-4 times. Draw as well as state the laws and make a practice. Now this diagram is drawn keeping the plane mirror horizontal. Sometimes in the exam you are asked to draw the ray diagram and mirror is placed vertical. Let's say mirror is as it is on the screen now, and incident ray will be given on this. Let me draw an incident ray also. Now you have to complete this diagram. This much is the question now. Since we know that this is a point of incident, right? Point of incident. Now you have to keep a protector right on this point in such a way that the rest of the 0 marks will coincide with the plane of the mirror, right? You have to make sure that this exactly will be here. Now this is what is the 90-degree mark, and your normal will come this way. And how much is the angle here? You have to see. So it is 10, 20 and 30. So it's 30 degree here. That means according to the laws of reflection, angle I should be equal to angle R, angle of incidence equal to angle of reflection. So from here 10, 20 and 30. So this is the point, right? We have to mark it and then draw the light ray. So take out the protector and then draw the light ray. So your diagram is this. Now suppose if another light ray is given. Again you have to keep a protector there. Make 90-degree normal. Find out how much is the angle from here to here. It's again 30 degree, right? It will be 1, 2 and 3, 30 degree. So from here also it will be 30 degree, right? Somewhere here the light reflected ray will go. See, 2 light rays which are parallel will reflect parallel, right? Keep this in the mind. Let us take another illustration. Here is vertically placed plane mirror. Let me go for one more plane mirror in such a way that the angle between them here is 90 degree, right? Now here I am going to give you a incident ray. So for that let me take a protractor and keep at a particular point and draw that incident ray. The angle between the plane of the mirror, this is plane of the mirror, and the incident ray is 50 degree here, right? Now you have to draw the normal and then reflected ray you have to draw, and then that reflected ray will go and hit on this plane mirror. Again it will reflect from there, right? So your question is complete the ray diagram if the following picture is given as a question for you, right? What you have to do now? You have to draw this as a question. And how you have to draw? The angle between the surface of the plane mirror and the incident ray is 50 degree. And use the protector and complete the picture. That means where will be the reflected ray, and again it will reflect from another mirror. Complete this diagram and practice it, right? Thank you. We will see you in the next video.